by a cage, which keeps them evenly spaced around the races. In addition to these parts, there are a lot of optional parts for special bearings, like seals to keep oil or grease in and dirt out, or screws to hold a bearing in place. We won't worry here about these fancy extras. Almost all parts of all ball bearings are made of steel. Since the bearing has to stand up to a lot of stress, it needs to be made of very strong steel. The standard industry classification for the steel in these bearings is 52,100, which means that it has 1% chromium and 1% carbon, called alloys when added to the basic steel. This steel can be made very hard and tough by heat treating, where rusting might be a problem. Bearings are made from 440 coulomb stainless steel. The cage for the balls is traditionally made of thin steel, but some bearings now use molded plastic cages because they cost less to make and cause less friction. The basic material requirements of precision roller bearings largely depend on the working performance of bearings. The selection of materials for rolling bearings has a great influence on their performance and service life. In general, the main forms of the damage of rolling bearings are fatigue spalling under the action of alternating stress, and the loss of bearing accuracy due to friction wear. The manufacturing process for giant roller bearings is complex and requires specialized equipment and expertise. The bearings are typically made from high-grade steel that is forged and machined to meet precise specifications. The rollers and races of the bearings are often heat-treated to improve their strength and durability. Because of their size and complexity, giant roller bearings can be quite expensive. However, their durability and reliability make them a cost-effective solution for many heavy-duty applications. Tapered roller bearings are commonly used in drivetrains or wheel bearing arrangements of commercial vehicles. In the German automotive industry, more than 10 million tapered roller bearings are used annually. They can support comparably high loads due to the linear contact between tapered rollers and raceway. Due to their contact angle, these loads can act in radial, axial, and combined directions. In addition, they can support high tilting moments in small installation spaces without the need for support of additional bearings. Tapered roller bearings usually operate under both grease and oil lubrication. Radial tapered roller bearings consist of an inner and outer ring between which the conical rolling elements are located. The conical rolling elements are guided along the inner ring rib. In loaded tapered roller bearings, considerable frictional dissipation occurs between the rib and the roller ends, particularly at low rolling speeds. Start-up and maneuvering are common cases in which low rolling speeds occur in wheel bearings of a truck. This can lead to a risk of wear and, in severe cases, failure. The increased frictional dissipation occurs due to insufficient lubricant film thicknesses in the roller and rib contact. Testing and commissioning. The press undergoes rigorous testing to ensure it meets performance and safety standards. To be able to forge such a large object, only these giant machines can meet the requirements. It is not only strong but also skillful to be able to forge steel structures according to requirements. Always need high precision in each step, because these details are not cheap. If just one of the important steps is wrong, these giant lumps of steel may have to be taken to the scrapyard for recycling. The open die forging press impresses with its huge pressing force and overturning force with high travel speed and forging speed, as well as flexibility and high productivity. A billet weighing about 30 tons and with a temperature of 1250 degrees Celsius is taken from the furnace. It is transported by crane to the forging press. The manipulator takes over the ingot and places it into the press. The forging press is prestressed with tie rods, giving it its high rigidity and precision guidance. The operator controls the forging process on this workpiece. The HUD section of the ingot is The rough-cut races are put into a heat-treating furnace at about 1,550 degrees Fahrenheit, 843 degrees Celsius, for up to several hours, depending on the size of the parts. Then dipped into an oil bath to cool them and make them very hard. This hardening also makes them brittle, so the next step is to temper them. This is done by heating them in a second oven to about 300 degrees Fahrenheit, 148.8 degrees Celsius, and then letting them cool in air. This whole heat treatment process makes parts which are both hard and tough. The inner and outer ring raceways are segments of cones, and the rollers are tapered so that the conical surfaces of the raceways and the roller axis, if projected, would all meet at a common point on the main axis of the bearing. This geometry makes the motion of the cones remain coaxial, with no sliding motion between the raceways and the outside diameter of the rollers. This conical geometry creates a linear contact patch, which permits greater loads to be carried than with spherical ball bearings, which have point contact. The geometry means that the tangential speeds of the surfaces of each of the rollers are the same as their raceways along the whole length of the contact patch, and no differential scrubbing occurs. The rollers are stabilized and restrained by a flange on the inner ring, against which their large end slides, which stops the rollers from popping out due to the pumpkin seat effect of their conical shape. The larger the half angles of these cones, the larger the axial force that the bearing can sustain. Larger, gigantic. The wording quickly makes frequent use of superlatives when it comes to describing the world's largest and most powerful hydraulic closed die forging press. Today's machines are becoming bigger. Their components are becoming larger, their geometries are becoming more complex and sophisticated, and demand a higher press force for their production. A gigantic hydraulic forging press is a marvel of modern engineering. These behemoths are capable of exerting tremendous forces, on the order of millions of tons, to shape massive pieces of metal. The largest hydraulic forging press in the world is located in China and has a capacity of 80,000 tons. That's the equivalent of the weight of 160 Statues of Liberty. Hydraulic forging presses are used to create a wide variety of products, including aircraft landing gear components, turbine blades, and oil well equipment. The forging process itself is quite simple. A hot piece of metal is placed between two dies, and then the press ram applies pressure to force the metal into the shape of the dies. The use of hydraulic forging presses has several advantages over other metalworking techniques. For example, hydraulic forging can produce parts with a very fine-grained structure, which makes them strong and resistant to fatigue. Additionally, hydraulic forging can be used to create parts with very complex shapes. The forging hydraulic press is a massive machine used to exert incredible pressure to shape large pieces of metal. The base of the press, a giant steel structure that houses the other components and absorbs the forces generated during forging. A large cylinder containing a piston that expands and contracts using hydraulic fluid to create the pressing force. Large, flat plates that sandwich the metalwork piece between them. The movable platen is connected to the piston and applies pressure to the workpiece when the piston extends, a system that generates high-pressure hydraulic fluid to drive the piston in the cylinder. A computer or hydraulic control system that regulates the pressure, speed, and position of the moving platen. In 1794, Welsh iron master Philip Vaughan patented a design for ball bearings to support the axle of a carriage. Development continued in the 19th and early 20th centuries, spurred by the advancement of the bicycle and the automobile. There are thousands of sizes, shapes, and kinds of rolling bearings. Ball bearings, roller bearings, needle bearings, and tapered roller bearings are the major kinds. Sizes run from small enough to run miniature motors to huge bearings used to support rotating parts in hydroelectric power plants. These large bearings can be 10 feet (3.04 meters) in diameter and require a crane to install. The most common sizes can easily be held in one hand and are used in things like electric motors. In these bearings, the rolling part is a ball, which rolls between inner and outer rings called races. The balls are held stretch-forged as a gripping neck. The workpiece is then reheated. In the meantime, the press is fitted with an upsetting plate with a hole for the gripping neck. The upper offsetting plate is positioned by the manipulator. The workpiece is positioned again. The ingot is now upset. The clamping and tensioning neck controls are forged under program control, so the material receives a uniform high-quality microstructure throughout the core. The workpiece is first forged into a square shape, then into shape octagonal. The finished forging is shipped away for quick refitting. The forging plant has, among other things, a sliding die for 3 dies, a table shifting device, and an upper clamping and rotating device for quick tool changes. A polygonal billet weighing about 70 tons is formed here again, formed by tension forging of the clamp neck. During the forging process. Frame construction. The frame is welded from large sections of steel and reinforced to withstand the immense forces involved. Hydraulic cylinder. The cylinder is machined from high-strength steel and honed to create a smooth surface for the piston. Seals are installed to prevent hydraulic fluid leaks. Platen assembly. The platens are machined from steel plates and treated for wear resistance. Guideways may be incorporated to ensure proper alignment during movement. Hydraulic power unit. High-pressure pumps, valves, piping, and a reservoir are assembled to create a system capable of generating the required hydraulic pressure. Assembly and installation. The individual components are assembled and mounted within the frame. Pipelines are connected to route hydraulic fluid. Control system integration. Sensors and control valves are integrated with a computer system to regulate the press operation. Safety features are incorporated.
这个这个冲压模式，先做到直接就做冲锋。
3到8斤，4到8斤。
要求太高了。